Hey guys, welcome back to another episode of Learning Kafka series, and this is episode 3. In today's section, we are going to talk about the main 6 components of Kafka and its architecture. So today's video is going to be much more important from theory perspective, as well as fundamental perspective, as well as interview questions as well. In this video, we are going to talk about 6 fundamental components of Kafka and how they are getting arranged to make the whole picture works, right? Uh, so with this introduction, let me dive straight into, what are these 6 components. So first component is Kafka broker. Second component is Zookeeper. Third is producer. Fourth is consumer. Fifth is topics. And sixth is messages. So these are 6 basic blocks of Kafka and we need to understand it very thoroughly. So straightly dive into that and let's see what is the Kafka broker. Okay, so let's try to understand from the theory perspective first. Kafka brokers has a responsibility to receive and store the messages, which is by from the producer and serve the consumer, right? So we can consider a block. A broker is basically a block which is placed in between publisher and subscriber. What's its responsibility? Its responsibility is simply to receive the message from the producer and send it to the consumer. That's all. So it's kind of a middleware. Let me quickly go into this diagram and let me show you. See, these are the 4 basic blocks I have written. So basically, if I'm saying this is producer, this is consumer, right? And this is something called as broker, right? So producer is producing messages or sending messages to the broker. And then the responsibility of broker is to send it to consumers, right? And this is basically Kafka, also known as Kafka cluster, right? It is a single physical server. You can consider this as a single physical server. Let's move it to the second part, okay? It's a single physical server. That means it's a separate machine who's doing all these tasks, right? So it is completely separate from the producer. It is completely separate from the consumer. It is separate physical server, which can run multiple Kafka independent brokers, right? So currently what we have seen is only one producer is sending sending data to, let's say, one broker, and one broker is sending to consumer. So this is producer, broker, consumer. But what will happen if this broker gets down or the server fails or computer shuts down, right? So producer, even if producer is consuming message, consumer cannot get it, right? Because the broker has been filled. So in this case, what happens is instead of single broker, what we can do is we can avoid this single point failure by generating or by creating multiple brokers, right? So let's say this is a producer, right? And instead of sending to one computer or one broker, we can create multiple brokers, let's say B1, B2, and B3. And all this is managed by, let's say, Kafka cluster. Now we are talking about multiple servers or multiple machines which is interconnected via a network. And that's why this block containing multiple brokers, even if one block fails, other two blocks can get the messages from producers like this, and then they can send it to consumer. So there is no single point failure, right? So what I'm saying is multiple producer and multiple consumers can read via one broker. That is another case. But what would happen if single point, this is single failure happens, right? That's what we just discussed, right? So if there is only one broker, the connection between producer and consumer will fail. But instead of one broker, if we can create the cluster of brokers, multiple brokers, then basically we can avoid single point failure, right? Hence, the broker cluster is created, right? So this block is known as broker cluster. Why? Because it has multiple broker instances in it, right? And this is also known as Kafka cluster or broker cluster. Another advantage, it is easily scalable, right? So tomorrow, if I want to add one more broker cluster here, B4, then it is really simple to add because we just want to add the new server into the same network or into the same cluster, right? So it is easily scalable. So even if one broker failed, another broker will take over, right? But now the main question is how this broker sync, maintain state, and share the workload, right? So basically, if I have, let's say, 4 brokers, how will I get to know, how this producer will get to know to which broker I have to send the data, right? How will this producer know if the broker 1 is failed or broker 2 is failed? how it will know, right? So basically, how these brokers are communicating with each other, right? It is very common question which can come into our mind, right? And this is where the second component, Zookeeper, comes into picture, right? So basically, if we again go back to this diagram, this block is called as Zookeeper, right? And it's basically, if we say this, right? So here we have mentioned we have multiple brokers, like let's say B1, B2, B3, so on and so forth. We can easily add the brokers, we can easily subtract the brokers, right? All these brokers are connected with each other via network, right? But how they're communicating with each other is via Zookeeper. So basically, Zookeeper acts as a manager here, right? Which basically keeps track of each and state of each and every broker, right? So it basically states, okay, B1, okay, B2, okay, B3, okay. So all this kind of statuses or the management part of it is maintained by Zookeeper, right? So because Zookeeper is acting as a manager, it is known as resource manager. Zookeeper is also known as resource manager. Now, it's continuously watching the states, right? So as soon as the B1 goes down, so it will say that it is not okay, right? And whatever messages are getting to B1 or data is getting into B1 by the producer, it's Zookeeper's responsibility to say that, hey, producer, now send it to B2, right? So all this management stuff is done via Zookeeper. Now let's see theoretically what this Zookeeper is, which is the second component of Kafka. The Zookeeper manages Kafka's metadata, so which include leader election, configuration, states, whatever we have just seen, right? So it is all maintained by Zookeeper, and it is known as metadata. Metadata is managed by Zookeeper. The default port on which the Zookeeper is active is 2181. Again, simple interview question. If multiple Zookeeper, then we have to create different config files. So this is basically a practical part. We will see when we are performing the practicals, right? We'll see how to start Zookeeper, how to maintain Zookeeper, what is this port is all about, right? We'll see that. This is the practical part. It maintains the config of topics and partitions. We haven't seen topics, we haven't seen partitions yet. Okay. But again, for example, again, this case, right? So let's say this is the broker cluster, right? And this is managed by Zookeeper. Okay, so it is keeping all the states of this broker cluster. But what happens if this Zookeeper fails, right? So basically this brokers B1, B2 will not be able to communicate with each other, right? So in general, complete broker cluster fails. This is very risky. So in this case, this is again single point failure if you observe. So in such case, what happened to cluster? To manage this broker cluster, again we are setting up multiple instances of Zookeeper, let's say 3 Zookeepers. And again, instead of single Zookeeper, we are basically creating Zookeeper cluster, right? So if one Zookeeper fails, another Zookeeper takes over, and basically all these Zookeepers are in sync. So everybody knows what is the state or the latest state of this broker cluster. Clear? Again, so what we are doing is basically we are identifying what is single point failure, and we are creating replicated instances of it, so that if one instance goes down, another instance can take up. And again, because we are creating Zookeeper cluster, which is also known as ensemble, right? Here I have written ensemble. Then basically it is becoming scalable. So we can add one more Zookeeper very easily. We just add one more instance of a server into the cluster, Zookeeper cluster, right? So it is horizontally scalable. Now, the next question is, what is the ideal instance number of the Zookeeper which we want to add or keep in the production cluster, right? And why? Okay, so is 2 Zookeepers are enough, or shall we do it 3, or shall we do it 4? What is the best practice in the industry, right? And if you know the answer, you can comment down in the description, or you can check the below document to get this answer. So to get this answer, it is something related which is called as quorums, right? So I don't want to discuss that deep in the current video, but I have listed down the document which has the complete guide about how many instances of Zookeeper you want to maintain in your production cluster. With this note, let's get to third component of Kafka architecture, right? The third component which we've been already talked about is known as producer. So the main responsibility of producer is to publishing the messages. Okay, what are messages we are going to see, but for now you can just consider it is kind of a data. So what is Kafka? Kafka is streaming the data from producer to consumer, right? So what kind of data it is? It is in the form of messages. We haven't seen the messages yet, but just remember that it is some kind of data that needs to be transferred from producer to consumer via brokers, because in between there is a broker block, right? They push the data into specific topic partition, right? What is topic? This is also we haven't seen, right? But I'll tell you what it is. They push the data into topic, which is in the broker. Inside the broker, there are multiple topics, right? And from that topic, the consumer gets the data. Producer can choose partitioning strategies like round robin and key based, right? For example, if I'm a producer, right, and this is a broker cluster which has, let's say, containers, multiple containers, right? And in any of these three container, let's say this is topic containers, three containers. So as a producer, I can send data to first container, second container, third container, right? Everything is like similar to me. I can do random choice, or I can build a strategy around it as a producer, right? So those strategies are nothing but round robin, key based, and there are multiple strategies just to see to which container or to which topic partition I have to send the data, right? They support acknowledgements to ensure the message durability, and producer use batching and compression to optimize the performance. So basically, if there is a huge data, I can compress the data and send it, right? So they have that facility as well. But how to run? There is one simple command. See, all these commands I have written here: how to start Zookeeper, how to start broker, how to start producer, consumer. All these things we are going to see in the practical session. But today we will mostly focus on what are the theoretical concepts. Producer, simple, which is publishing the data to Kafka or sending the data to the Kafka. Instead of data, we have said the messages. We'll see what are the messages. Okay. Now the fourth component is consumer. Very simple. Consumer reads the messages from Kafka topics, right? Which are nothing but brokers. From the brokers, the data is sent to consumer, which we have seen here, right? From the brokers, basically in the broker, there are multiple topics, let's say T1, T2, and the responsibility of consumer to get the data from that topic into the consumer. Clear? This is the simple explanation. Okay. What are the next points? They belong to consumer groups. Okay. So if there are multiple consumer, we can create a group around it as well. Kafka tracks the last read offset to ensure the reliable consumption. So Kafka keeps track of how many messages consumer has consumed, right? Consumer can use auto or manual offset management. Okay, they can pull the messages from the brokers rather than brokers pushing them. So whatever we are seeing, the arrows, now we have to update our understanding. So broker is not pushing the messages. No, this is wrong. So basically, it's responsibility of consumer to pull the messages from the broker, right? It's the effort from the consumption end. So this arrows doesn't make sense now, right? So it's responsibility of consumer to find the topic, right, they are interested in, and then get the data. So basically pull the data. So the arrow is something like this. Okay. So these are the consumers on high level. Now let's see what are the topics, right? Topic can be presented on one or multiple brokers. Very simple. So topics are basically, if I have one broker, inside one broker, I need to create a topic to store the messages. It is just a container, but it is very mandatory to create. I'll just give you a normal example. In my computer, can you directly store the data? Can you create the file if you try to right click? Do you see to create a new file or copy paste the file? No, right? First, you have to create a container or the local drive. Let's say drive C. And now inside drive C, I can create multiple folders. Now here I get option to create new folder, new shortcut, new image, anything, right? But first, I have to create one container. So just if we take the same analogy here, so topics are nothing but containers inside the brokers, which are required to create to store the data before storing the data, right? Who manages assigning topics to brokers? Any idea? Right? So these are zookeepers again. Right? So zookeepers, as we mentioned, it deals with all the metadata. So statuses of the brokers, topics, which message gets assigned to which topic, all these things, all the metadata is handled by Zookeeper, right? Right. topics are where the messages are stored. We haven't seen messages. So what are messages? It's nothing but a data. So topics is basically where the actual data is getting stored. Inside the topic, data is getting stored, right? New messages are appended at the end only. So let's say I have added message 1, I have added message 2, I have added message 3. Now I want to add the message between this here. It is not possible, right? So every new message has to get appended at the end only. If this is the end, new message will get appended here. Okay. If I want to add it here, this is not possible. Okay. And default log retention period is 168 hours, which are nothing but 7 days. So let's say this is message of day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8. By default, this message will get discarded or the deleted from the topic automatically. Clear? I think the topics are clear, right? So topics are nothing but container inside the broker and where the data is actually stored, right? And lastly, the messages, the most fundamental part. Messages are nothing but the data which is exchanged between producer and consumer via brokers. Brokers, or we can say via topics, right? What's the message structure? So does message have structures? Yes, it can be a normal text message or it can be a JSON message. If it's a JSON message, JSON is nothing but the key value pair, right? So basically this is key, this is value. Or it can be simple text like XYZ, right? So if it is a JSON message, it consists of timestamp. It consists of offset, which is unique across all the topic partitions. It has the unique key, and the value associated it, right? And it's recommended to keep the message size slow. So it's not recommended to send like 1 GB of file from the producer to consumer via Kafka, right? It is specifically designed for the low message, the low volume message or low size message. So these are all these concepts, the 6 fundamental building blocks of Apache Kafka. And if we see the architecture, we have seen here the producer, right? Producer are basically produces or sends messages to broker and specifically topics within a broker, right? So broker has nothing. Okay, let me clear this a little bit. Okay, so brokers are basically it can be a single broker or it can be multiple brokers. So let's say here B1 and B2. Right? Inside brokers, to store a message, first we have to create the topic. Let's say T1, right? So this messages is nothing but a data which needs to be transferred. This data can be in the form of what? Text and JSON. And if it is JSON, it consists of key value pair, KV pair, right? This message is getting stored into what? Topic inside the broker, right? All these brokers are managed by what? All these brokers are managed by Zookeeper, right? And once the message is stored, what is by default retention period? Anybody? This is 7 days, right? So message can reside into the topic of the broker by default 7 days, right? And consumer is nothing but to consume the data, consume the messages actively, or I can say proactively. What does it mean? It pulls the messages. It pulls the messages. It pulls the messages from the topic, right? And consume it, right? Zookeeper is basically a resource manager. It deals with the metadata of all the Kafka components, like broker components, what broker is up, what broker is down, how to manage the controller, how to manage the leader, how to maintain the metadata. All these things is done by broker. Now, the important thing is this Kafka broker or the broker cluster is completely independent of producer and consumer. So if producer failed, this Kafka broker cluster does not have any impact. If the consumer fails, Kafka broker does not have any impact. In fact, broker or Kafka cluster doesn't know how many producers are there, how many consumers are there, right? In real time, n number of producers can be there, n number of consumers can be there. So Kafka cluster or the broker cluster, which is one and the same thing, is completely independent on how many producers and how many consumers are there. So that's all for the today's session. I wanted to focus more theoretically on components and architecture of Kafka. There are total 6 components which we have covered, and also we have covered how to manage the single point failure by adding the multiple nodes into it. I hope you have enjoyed today's session, and I'll see you in the next session. Thank you.